Hi all, in this video we are going to see about the ADC configuration and how it works. Open the STM32Cube IDE. Select the workspace where your project have to be stored. Click Launch. From the file, select New. Click STM32 project. Today I am going to use STM32F205 RCT6 controller. From the right side also select the same controller name. Click Next. I'm giving the project name as ADC and I'm using C language, so I am selecting the targeted language as C and the targeted binary type as executable. Since I'm going to use the all APIs and libraries, I'm selecting the targeted project type as STM32Cube. Then click Finish. Under the system code, from the sys, select the debug mode as serial wire, and from the RCC, select both the high-speed clock and low-speed clock as crystal ceramic resonator, and from the analog, select the ADC2 channel, and in my customizable controller, ADC2 is connected to the port 2 and channel 11 is connected to it. So I am selecting channel 11 here. Coming to the configuration of the ADC2, here the mode is independent mode and the clock prescaler value is divided by 2. ADC resolution is of 12 bits, and since here I am using only single conversion mode. If you are using more than one conversion mode, you can go for the continuous conversion mode, and if you are connecting more than any number of nodes, you can go for the scan conversion mode. And here E of signal is generated, that is end of conversion selection signal. I am generating it. On your right, you can see the pinout diagram. Here in my board, PC1 is connected to the ADC2 channel 11. You can see that it is configured here. Coming to the clock configuration, 16 MHz clock is given to the APB and AHB timer clocks. Save your project to generate the code. Your code is generated here. After generation of your code, save the project and then build your code. The project is built with zero errors and zero warnings. I am going to debug the project. I have connected my STM32F205 board using the ST-Link V2 debugger. On your right side top, go to the live expressions. Here in this program, I have copied my ADC output values in a read register. I am going to see the output in the read register. Now resume the program. You can see the output in the debugging window. If I vary the port 2 in the controller, then the output value will be varied. The ADC range varies from 0 to 4096 since it's a 12-bit resolution ADC. Thank you for watching. Watch our videos regularly and keep supporting us.